Hello, everyone. Thank you for coming. So I do have some agenda today. I know that you guys might be a little bit anxious about programming test number 1, for which I released the guide yesterday. However, I really want to clarify any doubts as early as possible. So what I will do is I'm going to handle all the questions related to lectures or tutorial first. It doesn't seem like we got many questions today anyway. And then once I'm pretty sure all of you are okay about lectures, and then I'll move on to answer any questions you might have about programming test number 1. All right. You still have time to get prepared. So I also want to give you more my personal tips about how you should get prepared for your programming test number 1. But don't worry, we'll get there. All right. Okay, let me start with the questions you guys have. I don't have that many. I checked your Google Doc about 2 p.m. Right before the session. Not many, just about 2 or 3. That's okay. They are good questions anyway. I wouldn't imagine there would be so many questions before the reading week because we're still talking about something you have seen either in 10.12 or 10.15, about if statements or loops. You might have maybe a little bit more questions when we get to loops, because around the second half of the loop lecture, once I introduce to you the syntax about loops in Java, I will get down to very tricky logical issue, which might be very common for programmers in Java or in just programmers in general. That's around that point, you might have more questions. But of course, after the reading week, you'll definitely get more questions, I hope, about the objects once we get started. One thing at a time. All right. As I said, I'm going to talk about your fellow students' questions about lectures. And as usual, I know you guys are very polite. You simply just put a raise hand icon before I call you. I would say you can put a raise hand, but hopefully I'll see you in time. Otherwise, please just speak up, right? It's okay. I don't mind being interrupted. Just interrupt. That's definitely fine. All right. All right. So let's now try to look at the first question. This one is from Michael, I believe, right? Well, he put it on the question, so I got to respond to it. Nothing to do with the course contents. So I think if you recall the maybe week number 1 and 2, I use heavy metal music as the example in my lecture. So Michael was wondering if I'm happy, like a heavy metal music fan. Michael, are you here? By the way, if you're here, this question is for you.
I am.
All right, Michael. Yeah, I put it so serious right over here. Okay, the response to you, I'm not. I could be a heavy metal music fan, but I'm not. The reason I like to mention heavy metal music was my best friend. He is actually a heavy metal music fan. He's a big one. So that's why I would like to joke about it when I speak to him. Are you a heavy metal music fan?
I like some, yeah.
Have you heard? Do you know Metallica?
I like some bands. Yes.
Metallica, yeah, okay, yeah.
Yes,
I only know the name. I haven't heard about their music. Sometimes my friend asked me to download the music from iTunes for him, but yeah, okay. Metallica, Korn as well.
Oh, yes, okay.
Korn, anyway.
I know those two, yes.
All right. Okay. Anyway, just a response to you, Michael. Okay, guys. Sorry about the irrelevant things. If you're a heavy metal music fan, good for you. But unfortunately, I'm not. All right. Anyway, get down to Java over here. I think your fellow student here got a very good question over here. Basically, he was wondering about for your BMI app. I think that's about the lab 1 you just submitted. Okay. About using the double. So it's a very good challenge over here. I think that's a legitimate question over here. So why are you using double when float is actually sufficient? Also, why isn't short used more frequently in Java as opposed to int, I suppose, right? So here we talk about 4 data types over here. We talk about double, we talk about float, and also we talk about short, we talk about int. The green ones are floating point number data type, and the blue ones are the integer data types, right? So the difference really is about the capacity of the box, the capacity of the data type. So you can think about double is way larger than the float, and for integer is way larger than the short. And I would say it's not really the focus of this course. I don't think that would be the focus either in your 2030. I mean, the second year course. It's not really the focus about fine-tuning the storage of your variable, about whether you should choose integer or you should choose short, or whether you should choose double or you should choose a float. I would say in principle, it's not really the focus for for our context for the course. Okay, we'll discuss a little bit more into the logic about the language, not just about choosing the right storage. So here will be my, I'll show you some example here since your fellow student asked. So I would say for this course, using either float or double for your floating point number, both will be okay, because I don't think we're going to have any test input value that's going to be beyond the storage capacity of float. Similarly, if you want to use short as opposed to int, that's also fine. I don't think we're going to use any number that's going to be larger than the capacity of short, right? Let me make it clear. However, what I would suggest is, as said in the tutorial videos and possibly in the lecture as well, you can safely just always use double and also int. That would be okay. Okay, I would say that's always the safest choice, just in case. So what do I mean, just in case? If you actually choose the float, for example, right? Let's look at this table here. I simply did some very quick Google about, for example, capacity, like a capacity of float versus double. Okay, so you don't have to worry about the exact number, but I just want to show you. You can see we got the float over here, and then the maximum value is this guy over here. You might be wondering what this is. I will refer you to, actually we covered this very briefly. So this is so-called a scientific notation. And if you go back to the elementary programming lecture, where I talk about how you can write literals for numbers, floating point numbers more specifically. And this is how you specify the exponents, and then the exponent value is actually positive, right? So this is the maximum positive number you can store inside a float. That's the maximum. On the other hand, you can look at, by contrast over here, if you look at the maximum value for the double, you can see it's way larger. You can see the exponent over here is 308 as opposed to 38, right? It's much larger, right? Mathematically speaking. All right, so now if you actually declare your variable to be of double type over here, so that means you will be able to handle any input value positive until this upper bound over here. So this is more like upper bound of the value you can store. On the other hand, if somehow you didn't really understand the expected input value for your particular application, if you simply declare your variable as the float, however, if the user actually enter this particular input value, in that case, you're going to get very weird behavior in Eclipse, which I'm going to show you exactly. All right. Hopefully you follow my thoughts so far, right? Let's see one example, which I just created earlier, and then I'm going to make this available to you. So you can play with it further if you wish. Let's say we got two variables over here. We got float, we got double, right? We got f and d, okay? Let's say here we are simply just trying to use the maximum value over here. So you remember the maximum value that we just spoke about over here, the maximum value. I'm simply copying that verbatim over here. I'm basically trying to store the maximum value for double into a float, all right? And then in order to do it, you cannot just assign directly, because any number literal in Java is going to be interpreted as double, because in theory, it can go up to this large capacity. That's why it will be interpreted as double by default, all right? If you really want to assign some value that's by default interpreted as double into a float, you have to do some explicit casting. So casting, we also talk about it, right? This is just one use case over here. And then we're going to print out the value over here. However, even before I show you the result in Eclipse, you can think about there should be something wrong when we do this assignment over here, because the float, by definition, can only store up to this value as the upper bound. However, we are now storing a number that's way larger over here. That's what we are doing, right? We'll see exactly what happened. On the other hand, we just got another double variable over here, and then we're using just the same maximum value for double, right? Just the same one. And then in this way, in this case, it will be okay by definition, because double definitely can take just the maximum value that it can take, by definition. All right, hopefully so far you're okay with my thoughts over here. So I would suggest I will simply just switch to Eclipse over here. And then if I go to week number 2, I'm going to make this project available to you later today. If you look at that, under the default package over here, you will see max float over here. You can see these are the 4 lines I just explained on the iPad, right? So now let's kind of predict what's going to happen, right? If I try to assign something that's way too big into float, what's going to happen? If I assign something that's big, but still within the legitimate capacity for double, what's going to happen, right? They're going to be two outputs. Let's now simply run the program and let's see what's going to happen. If we do that, you can see, let's look at the second one. The second line is going to be the output from here, meaning that the double variable over here is just going to be able to handle this big number on the right-hand side. On the other hand, you can see this guy over here is simply just go beyond what the float can really handle. That's why when you try to store this number over here into the float, it will simply tell you that it's infinity. And mathematically, we know that you cannot manipulate infinity by infinity. So it's already, in some ways, already a logical error, even though things compile. All right, so that's about the response to your fellow student about this question over here. Any follow-up question to this, if you got any? Guys, any questions about float versus double? Anyone?
Hi, Professor.
Please, go ahead.
Just ask, in the labs, I'm not sure if you already answered this, but in the labs, it says to use floating point numbers. When it says that, it means using float or double, as those both mean floating point numbers, correct? And not just float?
Okay, I would say, thinking this way. So when we say floating point, number, right? Let's clarify the terminology first of all. When we say floating point number itself is a rather neutral term. Neutral. When I say neutral, meaning that it does not suggest whether you should really use a float or double. Float simply just happen to have the same name, part of the name as a floating point, right? So it's a neutral term. Okay. So what does it really mean when we talk about floating point number? It simply means you got some integral part, and then you have a dot, decimal point, and then you got some fractional part, right? Integral and also fractional. This is what a floating point number really means. All right. So now, whether to really use a float or to use a double data type to store the value is kind of up to you. All right. As I try to explain over here. So if you know very, very clearly that the input value can never be larger than this particular maximum capacity for the float, then using float will be safe. All right. Although, whenever you declare the float over here, if you want to assign some integer, for example, even if you say, I'll just give you one example. If you say float over here and f is assigned to 3.14, this is actually going to give you some error. All right. Because by default, any number literal, because in theory, any literal you write can go up to this particular value, right? So by default, compiler will simply say every floating point literal you write will just be interpreted as double by default. That's just the compiler decision. Nothing we can do about it. So that's why over here you have to say cast that to float. In that case, you will still get 3.14. That's not a question. All right, that's okay. All right, so that's about this guy here, and whether to choose the float or double data type. Okay, let's say outside the context for this course, let's say you're just programming in Java for whatever job you're doing. So whether you should choose the float or double data type, it's very important to ask yourself a reflective question. Okay, what's the maximum input value to be stored? That's really the critical question you want to ask yourself. If the answer is we are never going to go above this particular number for float, in that case, by all means, you should really just use a float to save a little bit of space. Even though the space you save here is really trivial, it's quite subtle. It's not going to really affect the performance of your code, so you don't have to worry too much. On the other hand, if your answer to this question over here is that some input value, maybe you're dealing with maybe some I don't know, maybe some scientific application where numbers can easily go above what the float can really handle. In that case, if you can go up to here, in that case, you really should use a double instead. Does that answer your question, maybe?
It did. So just one other part to that question then. So in this course, we can use float most of the time unless it has to do with scientific numbers, which
Yeah,
then
you
we
can.
should
Yeah,
use
in some way you're
double.
right. Okay, I would say for this course, let me make it clear. So let's make it very relevant. I would say for this course, you can easily just use the float without any problem. If let's say for either your programming test, either the first one or the subsequent ones, or maybe for your labs, if there's any danger or any erroneous scenario where using a float is going to cause error, I will explicitly remind you in the instructions. Otherwise, you can safely use the float. However, me personally, as I said, I don't really worry too much about having a very big box to store some very small item. That's okay, because for me, I just always use the double just in case. So, but for this course, you can either use float or double. However, when you use the float, you will just have to go with the catch over here. Whenever you're trying to assign some literal, floating point literal into a float, you have to cast.
Okay,
Make sense to
thank
you?
you, Professor.
Okay, very good. Yeah, that's a good question here. All right, guys. Any follow-up question to this one here about float versus double? Any more
Professor,
questions? Yes, please.
I just want. I was wondering if you can reiterate why you need to cast when you use a float variable.
Oh, sure. Okay.
Gotcha.
You mean you're talking about? Sorry, you're talking about this guy over here, right?
Yes.
Okay, sure. Let me explain it once more. Okay. What's happening over here? Let's double check this very quickly, right? So let me just give you one example here. So Eclipse float F2. All right, you can see that 3.14 is definitely some number which can be handled by the capacity of float. However, there is an error over here, right? Let's read the error. I think that's exactly why your fellow student was confused and put a question in the first place. Let's move the mouse over. There was a type mismatch. Cannot convert from double to float. All right, let's just remember this error. You can experiment it yourself as well. And how do we fix it? Let me just show you the fix and I'll explain again why. You want to cast this into float. All right, first of all, we cast it and into float. And then if we say sys out, let's say we try to print out F2 over here. All right, you can see that one's 3.14. So we haven't lost any precision. All right, so that's something you will see later. All right, so now let's talk about this one here. Okay, so if I say something like this, if I declare float, so that's a data type, and then we have, let's say, some variable, let's say f, and then if I simply say 3.14, okay, and then it's going to be a compile time error, right? It's simply not going to compile, and it's a type mismatch. So you want to think about this point over here, 3.14. We know that, first of all, it's a floating point literal. Literal in the sense that you simply just write out the number exactly, right? You got an integral part, followed by a dot, and followed by the fractional part, okay? And then number two, by default, all floating point literals, okay, floating point literals are interpreted as double. So from the compiler's point of view, this is simply just a double. And then you're saying that I want to store a value of type double into a float box, right? So in theory, it's not going to work, because what if the number is simply as big as this guy over here, just the maximum value, which can be handled by the double, but it cannot be handled by the float, right? Theoretically, there is such possibility. It definitely can happen, right? So think about every time you want to make a decision, you always got to think about the worst case, right? So your solution cannot just handle the best case to say, oh, maybe this might happen, but I never thought about if something very boundary or very worse can actually happen. You should always accommodate all the possibilities, right? That's the rationale. Okay, let's go a little bit further. So that's why this one here is simply going to be a error, because float is too small to accommodate some double value. And to be more precise, if you look at the maximum range over here, you can see, if you think about this number line over here, and then let's say this is the maximum for the float, max 1. And then this one here is the maximum for the double, max 2. You can think about this is the max 1, and this is max 2. So all the numbers that's beyond max 1 just cannot be handled by float. So in theory, you can also write a floating point literal on this range. So that's why they just cannot be handled, right, by the float capacity, right? All right, so now in order for you to really try to do this, you have to use an explicit cast. So how do we fix it? The fix would be, you still write the float f is equal to 3.14, but now you're going to tell the Java compiler the following. I know that this can in theory be just a double number, which might be too large for the float to really handle, but maybe this one here is just fine. I just want to overrule the compiler's decision. So I'm going to say, just treat it like a float. Put it like that. So I would say when the number is really not too big, in that case, by casting it, you're not going to lose the precision, right? As we just illustrated on the Eclipse. You can see after the cast over here, after we have stored 3.14, the cast version of 3.14 into the float, it will still give you 3.14 without losing any precision. All right. Does it make sense to you?
Thank you, Professor. Yes.
Okay, very good. No problem. All right, guys, any more questions? For those of you who actually program in the C family language, especially maybe C or C#, I think they also got data type like a float or double, something like that. So I think this will be something similar as well, right? This is more like a practical concern. All right, any more questions before I move on? Okay, since everybody's okay. All right, let me now move on to the next one over here. We only got 3 more actually. Okay, let's handle that. This one is more like a clarification over here. Let me read it together with you. We actually got, okay. Wondering what the formal definition of a unary operator. Okay, from your fellow students' understanding, simply an operator. Okay, fine. The unary operator, of course, is an operator that only affects one variable. Is that correct? All right. I wonder if any one of you is willing to speak up and then to see whether your fellow student understanding is correct. Or you want to either you can say that's correct, or you can try to provide an alternative version about defining what a unary operator is. Anybody?
Professor?
Yes, please.
May I try?
Go ahead, please.
So I would like to say an alternative definition.
Go ahead.
Unary operator is an operator that only affects one operand.
Mm-hmm.
Is that sufficient?
Yeah, I like your definition. Affecting one operand. Very good.
Oh, and Professor,
yes.
I was just looking at chat, and maybe after answering this, someone asked, Ali asked, with going over the float maximum, how would the program use infinity?
Sure, no problem. Yeah, let me finish this question here very quickly, and I'll go back to the maximum. No problem. Yeah, thanks for reminding me. Yeah, I'll do that. All right. All right. So I think it's Michael. Okay.
Yes.
Okay, good. Yeah, I just want to make sure. Yeah, I just want to make sure I don't really mess up get confused with the voice. So what Michael just said was completely correct. So the very definition for unary operator is you're only affecting just one operand by definition. What your fellow student said over here is it is not incorrect, but it's not complete. But not complete. Because when we talk about operand over here, let me just tell you the possibility over here. What can be an operand for the unary operator? And then I'll give you example. One operand over here. Number one, it could be some literal values, the simplest one. And then it could be some expressions. And also it could be some variables. Okay, let me, I think your fellow student was actually using some example over here. So minus over here, is it a unary operator? Depends. For example, if you say 2 minus 3, in this case, the minus over here is binary, right? Just to clarify. And also, if you say, for example, negative 23, in this case, the minus over here is unary, right? So you can, that's why I said in the lecture, the minus operator is actually overloaded. So it can have more than one definitions, depending on where you use it, okay? And then for the plus, this plus is always binary, okay? The exclamation mark over here is a unary operator. Specifically, it is for logical purpose. Okay, let me use this one as an example, okay? So now let's say for number one, literals, okay? So for number one, I can say not true. I can also say not false. You can think about these two over here are simply just Boolean literals. Right, either true or false. The result, you know that it's going to flip the result, right? Something you learn about truth table for the logical operators, right? So we will definitely dive even more into the logical operations when we talk about loops, which would be some very interesting cases you have to analyze, but we'll get there later. Okay, so that'll be case number one. You can see we are using a unary operator, logical negation, but you can see the operand over here does not have to be variable. So it can be, so that's why I said your fellow student definition is correct, but not complete. Okay, let's talk about possibility number two. What about expressions? You can think about it like this. I can say it is not the case that maybe x larger than or equal to 0. So this part over here, x larger than or equal to 0, is actually a relational expression, right? We also talk about it when we introduce the Boolean data type in your week number 2. So this is a relational expression or operation. And this part here is going to give you either true or false. And then the negation here is simply just going to negate it, true to false and false to true. Right? So this will be the second example where the operand for your unary operator can just be some expression. It can be arbitrarily complicated. Let me give you one more example, which you will see in your week number 3 lecture. Another example would be, let's say negation over here. And then I simply say maybe 0 less than or equal to x, and also x strictly less than 10, right? So this, you can think about this part over here is the operand for your unary logical operator, right? So this part is also going to give you either true or false. And I think you really want to get used to this pattern over here about using conjunction to specify ranges. I think that you definitely find this might be useful for your lab number 2 and also for your programming test number 1. You might also have to use the logical conjunction in this way. In your week number 2 and in your week number 3 Java tutorial video and also lectures, I actually dive deep into interpreting how to use logical conjunction. So hopefully you'll catch up with your study about the tutorial videos and lecture. All right. Finally, final thing to really to emphasize to illustrate would be about the variables. So now, as your fellow student said, variable, that's correct. Again, your fellow student didn't talk about 1 and 2, right? That's why I say it's incomplete. What about number 3? Number 3 is very easy. Think about this way. If I say this, I can simply try to do, let's say, Boolean let's say some B, right? Boolean B is assigned to, let me just say maybe 23 larger than or equal to X, right? Just some relational expression, right? Or it could be as this part over here, the right-hand side for the Boolean data type assignments, it can be as complicated as something like this as well. You can also do that, right? As long as the right-hand side source for the assignment returns a Boolean value, you can definitely use it to assign to this Boolean variable, all right? And then after this, I can say not the case B, all right? So this one here, you can think about this part here. So this B over here is a variable, and that one is really the operand. Oh, sorry. This is the operand. Okay, sorry, didn't spell quite correct, but it's the operand. It's the operand of logical negation. All right, so now we got 3 possibility over here. Possibility number 1, number 2, and number 3. So that would be the formal definition for what? The formal definition, like what Michael said precisely. Unary operator is simply an operator affecting one operand. And if you want to define a little bit further to give more details, you can talk about these 3 cases. All right. Guys, any more questions about this? Unary operator. Let me say something very quickly, right? I want to speak a little bit, go a little bit ahead. So this is something I will talk about in next week, in week number 4 lecture. We still got 2 or 3 more small topics to finish for your if statements. Let me talk about this guy over here, right? Let's say this. Boolean variable B, let's say it is assigned to, something. Whatever Boolean expression you might write, right? As I said, there are 3 possibilities. Let's say we do that. And then if I want to say if B is equal to true, and then I do something over here, otherwise I do something else. All right, I believe most of you, especially if you're a beginner, actually, even for the 3rd year students I saw in the software design course, much more ahead of you in the study, in the 3rd year, in the senior level, they still actually write things like this to say B is simply equal to true. All right, and as you will learn in this week's lecture, I'll just mention that, but you're going to see the reasoning in the lecture explanation. We know that you only get to the else part if the if branch over here does not evaluate the true, right? So which means it is not the case that B is equal to true, right? Implicitly. And then this is simply equivalent to, we say it is not the case that B is equal to true. So that means B is equal to false, right? It's not complicated logic over here. And then one thing you may get used to, hopefully at some point, when you write this one over here, wouldn't that just be equivalent to not B? That's why I want to mention this. And then this part over here, when I say B is equal to true, it will be also right if I simply say B. All right. So this is B over here and also not B, versus when I say B is equal to true versus B is equal to false. If you write the blue ones, that's okay. Maybe you're still trying to get used to the ideas about a variable either be true or false. However, using this either to say B or to say not B, that'll be okay as well. Because if you say if branch over here, what you want to do to decide whether you want to go to the body over here is to see if this expression over here will be true or false. If it stores true, you go into the branch. Otherwise, you don't go there. All right, guys, I think I'm going a little bit ahead. If you have already seen the lecture for this week, you would know what I'm talking about. If you haven't, hopefully that will make more sense once you follow the lecture. All right, that's something I want to say. But I do encourage you, don't worry about it. You wouldn't lose any marks if you didn't do it. In your labs or in your programming test, if you find that you have to write something like this, try to train your mind a little bit to see, isn't this simplifiable into just this. And when you're writing this in your Boolean expression, think about, isn't this simplifiable into not B? Okay, think about that. All right.
I have a question about that.
Please.
Is this type of shortening of the words, does that translate into other language? Like in Python, could you do the same thing instead of saying B equals C, you could just say B?
You mean like a B and not B over here?
Yeah.
You know what? To be honest with you, I'm not proficient Python programmer. Let me, you know what? I don't want to say anything wrong to you. Otherwise, Michael will be very upset if I say something wrong about Python. Let me put a question over here for Jackie, right? Python and logical.
Do you know if there's other languages where you can do this?
Yeah,
the same thing here.
Yeah. Let me for Python specifically, since you mentioned, I would say I'll find this out, and then I'll mention that tomorrow. However, you asked about other languages, right?
Yeah.
The answer is yes. I believe. So let's talk about the C language. If you say C, not really, because in C there's no such a type called Boolean. In C, you can only try to use the integer value to really simulate Boolean. But let's not worry about it. Okay. For C, you're going to learn about it in 2031. So I'll let you learn it once you get to the second year. Okay. Another language which will got exactly the same idea like this is called C#. Okay. So C# is actually what if you want to program some Windows application in Visual Studio. So for C#, they also got the exclamation mark just for logical negation. So they will have exactly identical reasoning process as I just said. It will be the same. Okay. Another one I can mention, another language over here, just for your information. There is a type of language called functional programming language. Think about Python is like a procedural language, right? You just define functions and then you try to, just write a lines of code. And Java is more said to be an object-oriented language, because you can create objects, which we will talk about after reading it. There is another paradigm called functional language. However, I can tell you that it's a very unfortunate thing. At the moment, we don't really teach you a functional language in our curriculum. We only touch a little bit about it. I forgot a course number, but there is a course for Introduction to AI in your third year. And I believe they use a language called Lisp. However, Lisp is to me, is a horrible language because you got lots of parentheses. But I'll let you have the fun when you get to the course, all right? But for the functional language, let me mention something quickly. There is a language, for those of you who might be interested in exploring some fun language, I would highly recommend this one. It's called Haskell. I would be very surprised if any one of you actually have had any experience about it in your high school. In that case, I think you should really thank your high school teacher, because Haskell is a very interesting language to learn. Okay. Anyway, so let me just talk about it very quickly. For Haskell language, the way they do Boolean is very similar, except that they use a unary operator called not, meaning that you don't really say exclamation mark, you simply say not. So if I have B over here, I'll say not B. Or I can say not B is equal to true, something like that. Okay, so back to your original question here. So the idea I'm talking about over here, if the programming language you're doing for yourself, if they do support the Boolean type, then this kind of a shorthand to go from this to this, or to go from this to this, they must exist. That's the short answer to your question.
Okay.
Okay. I hope that answers your question. All right. Yeah. All right. Your fellow student mentioned that also for Bash script, they also got B and not B. Sure. Okay. I don't really program Bash script a lot. Maybe that's true. Okay. By the way, in 2031, Bash script and also C will be the languages to learn. All right. All right. So that's about logical negation over here. Let's go a little bit further. All right. I think this one here, your fellow student's question was, let's read it together. Also related to logical negation. I'm not really surprised because logical negation, I would say, even though its definition is so easy, you would say from true to false and false to true. However, when you're using it in your code, it might be, sometimes it can be trickier to understand. then logical conjunction or disjunction. I will just review one example very quickly with you, and then I think I'll leave you maybe leave any further questions later. All right, let's say this. Does the negation logical operator automatically categorize the operation that's in compound Boolean expression? Okay, I think it is true. So now you can see not is positive or not. I think your fellow student was phrasing the question pretty well. So if you look at that over here, that's basically the case number 2, right? Where you actually got not the case, some relational expression. And also you might say not the case, some variable, like what I just explained. So all these are said to be compound expression. Okay, let me just mention that term. All these are said to be compound expression. Compound expression simply means you're applying some operator and then you're trying to build a slightly more complicated expression. Okay, that's basically what it says. And then I don't think I'm going to go into too much detail about this particular example. I just want to point to you, just to motivate you a little bit to really follow the week 3 lecture. I believe this example over here about computing the area of circle, which we have seen many times, but the main point to illustrate in this one here is like this. Let me point to you. You can see in one branch, we say if the radius input from the user is strictly less than 0, and then we're going to print out some error. On the other hand, you can see the second version over here, compute area 2. In that case, we only try to print out the error in the else part. And for your information, you can see the branching condition for the if is actually radius larger than or equal to 0, right? You can see radius larger than or equal to 0 versus radius less than 0. Less than 0 for version number 1, and also radius larger than or equal to 0. You can see we try to put one here and the other one over here. But somehow we can argue that these two programs, even though written syntactically in a very different way, but logically speaking, they behave the same. Meaning that if I give you, for example, some radius that's valid, which is positive, in that case, it's going to calculate the area and give me the result. On the other hand, if I actually give you some negative result, which is invalid, in that case, it's going to give you some error message in both cases. All right. So this is something I want to mention, recap very briefly what you're going to learn in week number 3. To really argue that the behavior for this and the behavior for this are really equivalents. You have to know this one here and this one over here, they are, number one, they are not the same for sure, but they're closely related. Can anybody tell me how are 1 and 2 related to each other? Anybody?
Professor?
Go ahead, please.
They're logical opposites of each other?
Exactly. Logical negation or logical opposite. Yeah. Yeah, okay. You can say 1 is equivalent to the negation of 2. Or you can say 2 is equivalent to the negation of 1, each other. That's exactly right. So guys, put this thought over here in your mind a little bit, because this is something I will explain in details, I believe, in the first or second part of your week number 3 lecture this week. All right. All right. I remember Michael mentioned that your fellow student was talking about some maximum bound. Let me go back there. Let me see the chat. Okay, from AV. With going over the flow maximum, how would the program use infinity? I think the point is over here. You can see if you're trying to store the number that's already beyond the capacity of the float, in that case, what you will get, what gets to be stored in F, is not a meaningful number anymore. It's simply just infinity. And once you get infinity, if you try to do, I didn't try. We can try it over here. For example, you can say float over here, F, let's say F3 is simply maybe F plus 1. over here, and then I simply say F3. Right? Let's see what's going to happen. Right? You can see infinity and infinity, which means the number you have stored into F over here, which is way beyond the normal capacity for F. So now if I try to do any further manipulation for F, you cannot do that anymore, because once you get to infinity, no further manipulation can be done by that to it. Right? Mathematically, we know that you cannot say infinity plus infinity is going to be 2 times infinity, right? It's simply, you cannot argue that way, right? That's why you got to be careful over here. So AV, did I answer your question over here? If you're still here.
Yes, Professor. You
Very good. No
question.
problem.
Thank you.
All right. No problem. All right, good. Let's now go back to next question. Okay, I think your fellow student was also asking me before I started the recording. I thought this would be useful for everybody to know. Something about a naming convention. Let me do it right away over here to show you. All right. Let me use an example over here. You know, I think this would be really worth mentioning, because for your programming test number 1, which I'll speak many more details a little bit later. Okay, I want to mention just the part related to JUnits. I think for programming test number 1, 2, 3, 4, you will not be required to really write any JUnit test. However, you're recommended to try writing some JUnit tests yourself. Okay, however, how do we do that, right? So what I would do is I'm just going to do over here class. Let's say utilities. Okay, of course, let's follow the convention we have faithfully. So let me say model. Okay, and then I'll just want to illustrate how exactly you can create a unit test. So I think you can also benefit from this for your programming test. I will put utilities over here. Let me define some very, very easy, simple method. Public static integer at integer I, integer j. Okay, and then I'll simply say, I'll follow the convention you're used to. Okay, although I can simply say return I plus j. I could, but let me say integer result. Initially 0, and then result is assigned to I plus j, and then return result, right? I just want to always have some initial value for the result and eventually return it. If you're more experienced, you can feel free to say return I plus j. That's fine too, right? As long as it works. Let me now create a JUnit test, and I'll explain the convention. Typically, when we say convention, that means you're recommended to follow, because you can assume your fellow Java programmers are also following the same convention. So when you see progress, it wouldn't be too deviated from the normal standard. However, if you really try to name the variables or methods in your own way, that's okay. Compiler wouldn't care about it, right? JUnit test. Okay, let's now create a test. New JUnit test case, and then I want to do JUnit test 4, and then test utilities. Finish. And then I want to put JUnit 4. Right. By the way, you don't need to create any JUnit test class in the programming test 1. It will be created for you, so we save you some time. All right. Let's say this. Now let me just create from scratch. You know what? I think let me just tell you exactly what you may do for your programming test. Okay, you will be given some test. I might say test the add method, and then I want to say O1, right? Number 1, and then you can always assume there's going to be only 2 lines for the JUnit test. I will get, for example, integer result is assigned to. Let me maximize it for you. For integer result is going to be assigned to utilities dot add. Let's say 3 plus 5. And then the second line is always going to be, you want to assert whether the expected value is matching the actual return value. So you would say assert equals over here, and then you would say, what do we expect to see? 8. And then I can say result. Okay, something like that. Let's say this. in your programming test number 1, you were given, let's say for this particular method you're asked to implement, let's say you already passed this test. But for your own good, you may just want to test maybe some additional values if you, to really make sure, even for the boundary values, things will still work. I would suggest you do this just to save, just make sure you wouldn't introduce any compilation errors. So how do we do it? Copy the whole thing over here, and then paste. Once you paste, you will definitely get this error over here because you got now you got 2 test methods with the same name. You will simply change one of them just by incrementing the counter from 1 to 2. As soon as you're done with it, there's no compilation error, which is good. However, in some way, the second test is simply a duplicate of number 1, so it's not very useful. But now you can simply modify the input value over here and then the expected value accordingly. So now I can simply say 23 plus minus 2. So that should be 21, right? You can see that's all I changed. Now I have already done 1 test case for myself. I'll recommend you practice this maybe for your labs and also for your also practice test to really create a new JUnit test. And then I want to address your fellow student question before the recording started. What about the naming convention for JUnit test? If I can remember correctly, when I was around your stage, when I was studying my undergrad for computer science, in my 4th year, that was my first time encountering JUnits. I forgot which version it was, maybe 1.1, 1.2. I think around that time, there was no such tag called @test over here, which means every method must start with the keyword, not keyword, must start with this lowercase, all lowercase word, test. If a method is actually starts with test over here, and of course the rest of the name simply doesn't matter, all right? As long as a test method starts with test, that means the JUnit's runtime is going to treat this method as a test case and then include it in the test report. On the other hand, if you didn't do it, if you simply say, for example, if I simply say @01, if I simply say that, in the older version of JUnit, since you didn't mention test as part of the name, it's not going to include it in the test execution, okay? I'm talking about older version, like in my days. But in your days, you're dealing with JUnit 4, for example. In that case, they introduced this idea about tag over here, meaning that even if you didn't follow this convention over here, as long as you put the @test tag, because it's case sensitive, it must be uppercase over here. As long as you put it, the test execution is going to be included anyway. All right, let's try. So now if I say run, you can now see both this and this are both being run, even though this method name over here is not really called test, right? Hopefully you kind of follow my flow over here. But I would still suggest, even though this tag over here will be enough to really say this is a test method, but to really make your method name even more explicit about its purpose, you may still want to say test over here. You may still want to do that. So you can see in your lab number 2, you can pay attention to how I name the test method for maybe the rock paper scissors game. In that case, I really try to kind of be very explicit about the what the test is supposed to do. However, how you name it, how you name the test method will be completely up to you, right? Again, it's a convention, meaning that even if I didn't follow the convention by getting rid of the test over here, I can still run the test. That's no problem. However, convention means it's recommended you follow it. All right. All right. Hopefully you kind of see the idea. All right, guys. Any more question about JUnit test? Let me say one more thing for you guys. I think that's also important for your programming test, which is about using debugger. I really hope all of you, either you're here today or you're watching the recording, you have at least tried how to use debugger. I can see some of your fellow students running into some trouble posted on the forum. If you're here, please speak to me maybe during the office hour. In that case, I can maybe speak to you about how to use the debugger more appropriately, right? I can speak to you. All right, so let me just mention one thing here. Let's say this. Let's say in your programming test number 1, somehow you just implemented wrongly. Maybe it's a typo. rather than I plus j, you say I plus I. So that's wrong, right? And then when you actually run the test over here, you will see that, let me just do it again. And you want to make sure your mouse cursor focus go outside the methods. And then let me run it again. You can see I failed 2 tests over here, right? So now you want to figure out exactly what's wrong. One thing to do first is to look under failure trace. You can see expecting 8, but was actually 6, meaning that we are expecting 8 over here, but your result is actually 6. But why, right? The best way to really find this out is really to use the debugger. So you will simply click on over here to set the breakpoints, right? That's what we did in the tutorial. And also I try to repeatedly try to demonstrate to you on the lecture. Put a breakpoint, and then you're going to launch the debugger over here. And then you're going to switch to the debug perspective over here. And then you can see over here. So this is the method we would like to go into to see what's wrong. All right. So now if I say step into this particular method call, and then now I'm in the context of the method that's being tested, right? So now if you see I and j, 3 and 5, and also I plus j is 8, right? So now if I just try this, if I say step over here, what it has done is it has initialized the value of result to be 0. So now think about what you expect to see. I would expect to see that after executing this line, I'll be ready to return. So if I say I plus j, I should get 3 plus 5. However, if I say step over, I actually got 6 as opposed to 8. So I would know there is something wrong from the line I just executed. In that case, I can look into it a little bit more closely and I realize, oh, I actually only added I plus I rather than I plus j. So this is actually how you use the debugger to find defects in your software, right? So what I'm talking about over here, to be honest with you, you might be thinking you wouldn't make a silly mistake like this. I can tell you when I was invigilating your fellow students in 1021 back in winter 19, I think one of the questions was something like this, to add 2 numbers. And what your fellow student typed on the screen was like I plus I. But of course, I couldn't tell them what they did wrong. But they were very positive about why they got the wrong return value. So if you really make such typo, it will be quite tricky for you to spot the typo. So using debugger might be the best way to go. All right, so I think that this illustration here is also part of my tip to you about how to get prepared for your programming test number 1 and also for all the subsequent ones. Basically, whenever you got any errors that which you don't really see immediately what happened, using a debugger might be the best way to go because you can actually walk over the execution line by line. So that'll be the best way to do. All right, so let me now go back to utilities, right? All right, guys, I hope it's not going to happen to you, but I did see this happening before to your fellow students, right? It did happen. All right, let's go back here. All right, so I think that's about naming convention here. Any more questions about JUnit test? Any more questions? All right. Okay, guys. Okay, now I don't have any more questions from the Google Doc. Before I speak about your programming test number 1, I would like to just ask, do you guys have any more questions related to lectures or tutorials? Any more? I'll give you priority. Yeah, please.
I have one more question.
Yes?
I thought I put it in the Google, but I guess it was my mistake and it wasn't there. My question is, I learned from my logic class that the conjunction operator takes precedence over the disjunction operator.
Yes.
So my question is, if you have, say, for example, like 3 operands and 2 binary operators, one of them is disjunction and conjunction. If you put the conjunction first, or sorry, if you put the disjunction before the if you put the disjunction before the conjunction, will the conjunction occur first?
Yes, correct.
Okay, I see.
Michael is a very good question here. I would say this issue here is about a precedence. About logical operator. So one analogy would be if you do 3 plus maybe 4 times 5 without any parentheses, right? In that case, we know it will be as if we actually bracket this first. It would be as if. So we say that multiplication has higher precedence. In the context of your logic, in your logic course, or in this course, which we also support logical operator in Java, you can think about this is more or less like a conjunction, and this is more or less like a disjunction. Okay, and then about exactly how to interpret this, short answer, it will be as if this was bracketed to be evaluated first. But now the interesting question is, if you're given this particular expression, let me just go backward a little bit. Okay, like that, like this. Let me put it here. So Michael, why don't we let you try quickly? Also, we can demonstrate quickly, right? This actually covered in your lecture this week. There are actually two different ways to bracket the same lines of operations over here. I can either try this way, or I can try this way. All right. 1 and 2. Are they equivalents? And let me be precise about what I meant by them being equivalents. Equivalence simply means given any values for P, Q, and R, evaluation result will be the same. That's what I meant by. So now think about how many possible input value can you have for P, Q, and R? How many?
8.
Aha,
8.
Very good. For those of you who may not know, okay, think about we got P and Q and R over here. We know that, well, very simple math. P can be either true or false. Q can also be true or false. R can also be true or false, right? And then you simply say 2 times 2 times 2. Very basic combinatorics, which you learn maybe in your calculus class or maybe high school, I don't know. So that'll be 8. So 2 to the power of 3. All right, good. So now, Michael, can you think about any value? Okay, first of all, do you believe they're equivalents or not?
I don't think they're equivalent.
Okay, and then how do you prove that they are not equivalents?
The truth table.
Well, you know what? I can tell you that very, very quickly. Just for those of you who might be taking a logic course, your professor might be talking about this anyway. So if I give you some statement over here, right? If you want to prove to me it is wrong, it is not the case, you don't have to say too much. You just got to give me one so-called witness to show me that my statement is simply just wrong. So all you got to do, Michael, is to give me one instance of combination for P, Q, and R, such that this is going to give me, for example, true, and this is going to give me, for example, false.
Okay.
Give it a try.
Yeah, if we let P and R be true and Q be false, then the first example.
Sorry. Yeah, let me do together with your fellow students. You're saying P, Q, and R. So what should they be?
If P and Q are true and R is false.
Okay, let's try. So P and Q are true and R is false. Right. So guys, I'll give you a little bit tip about it. I also show you in the lecture. When you are taking care of a conjunction, somehow if you got this simultaneously, we're humans, so we can it doesn't matter which way we process first, but for machines, they usually go from left to right. Since I see this is already false, I don't even need to look at this, right? Because conjunction means the only way for that to be true is when both are true. At least one side is already false, so it's going to be false. So the result from here, the whole thing is just going to be false. And let's look at the second one from Michael. Okay, I'll just illustrate it. Let's say this one here, true, true, false. And given that this is disjunction, I know that this part is already true. I don't even need to look at this, because the only way to make a disjunction false is when both operands are actually false. And at least one of them is actually true, so I know that the result should be true. So guys, hopefully you're comfortable with this explanation here. That's something we said when we try to define the logical operators. Okay. All right. So yeah. So Michael, so just go a little bit too far. Basically, we talk about precedence, but I think that this is something about when you don't really have any, when you actually got brackets around the logical expression, you got to be careful about how you're bracketing them, because different ways of bracketing might just give you non-equivalent expressions. All right.
Thank you,
All right.
Professor.
Any more questions? Anybody?
Yeah, I had one.
Please go ahead.
I just want, is debugger more or less the same in kind of all text editors?
Is debugger more or less the same as?
In different IDEs or code editors, does debugger pretty much work the same?
Yeah, more or less the same. Yes, you're right. I think some of your fellow students were a little bit disappointed that we wouldn't use IntelliJ for this course. I personally like IntelliJ, to be honest. However, just that, we want to be a little bit compatible with what you're going to use in 2030. So that's why we're using Eclipse. But anyway, yes. So when you actually go into any programming IDE, you're definitely going to, okay. It's a very important question here. Good question. When we talk about debugger, and let me say a little bit unfortunate facts that's going to happen to you in 2031, right? It was the case for my year back in 2005, a long time ago, but I don't think things have really improved, okay? Let's talk about this. Let me broaden the context for this discussion a little bit, okay? Let's talk about debugging, okay? Okay, debugging literally, it simply means to find errors in your code. All right. So in principle, any CS students would know there are two ways to do debugging. All right. One way I call the console way, which means in the Java case, you will simply say system.out.println, right? Conceptually, it works like this. Let's say this is your Java class, right? And then maybe this is some method you have defined. And then you simply got lines of code over here, okay? Somehow you suspect maybe there is something wrong in this line. Maybe you're suspecting. And following the console way, you will simply say, okay, maybe after this line, I'll simply say system.out.println. And then I'll simply try to print out maybe the variable value for X. And then I'm going to rerun my console application or rerun my JUnit test and see what value is going to be printed out to the console. So I would know this X is actually the result from this particular line. So I can judge to see whether that's true, right or wrong. If it is wrong, I can fix something accordingly. However, as you can see, the major drawback for approach number one is actually you're going to have lots of print statements in your code. In some way, you're polluting your code. Let's say if you are really trying to do, maybe not in 1022, but maybe later on when you get to 2030 or maybe 3311, right, about a software project that's really large scale. If you got maybe thousands of lines of code, and then you got so many mistakes, and then you put hundreds of system.out.println statement in your code, it's going to be very, very messy. And then what if, let's say after you have fixed all the bugs in your code, what happened to those system.out.printout statements? You're going to comment it out. And the next time if there's any more bug, you got to put it back. So you can see the very tedious and manual process, right? However, I can tell you, very unfortunate. I really hope it's not going to happen to you based on what I have seen in first year, second year, third year, or even the fourth year. More than 80% of your fellow students, I'm talking about students across the years in computer science, more than 80% of the students, when their software run into bugs, either in Python, maybe not in Python, I haven't seen Python too much, either in Java, or maybe in C, or maybe in another language for software design used to be called IFO, or maybe for other languages. So this will be how people debug the code. They simply try to print out something to the console, right? That's number one. The second approach is about debugger. Okay, so this is exactly what you were shown from week number 2. So you can think about in the same piece of code, I don't really have to pollute my code. I don't need to write any line into the code, extra line. I don't need to. All I need to do is I simply set a breakpoints over here, right? And then launch the debugger. So I will be switched to another debugging perspective, a different perspective from Java editing. And then once I go to this part over here, I can examine maybe the variables or the expressions, right? That's something we have seen so far in the tutorial videos. So this is a much cleaner and much better approach to really find the bugs. Okay, so now you can see either 1 or 2. I would say any programming IDE that you might run into, maybe IntelliJ or maybe some Visual Studio, they all support both. Okay, however, which one to use is kind of up to you. But I would say they will support debugger for sure. So I would highly recommend you do debugger, right?
Professor?
Yes.
When you taught us the JUnit method, is that considered 1 or 2?
Oh, JUnits. You know what? So here we're only talking about debugging, right? Debugging is once you already know there is a, okay, debug, it's different dimensions. When I say debugging over here, that means I already know, it's known to us. There are errors. However, when you talk about JUnits, you can think about JUnit is something that's related but not the same. Is to find errors. Okay, think about it's a flow. Well, I know you hate flowchart, but I'm gonna use some flowchart over here. Okay, that might be in this easy case. So think about basically you're basically going to edit your Java code, and then after that you're going to test your Java code, and then you may have to debug your Java code. Okay, and then after debug, you may have to just go back to edit and etc. Right? You can think about for the test over here is about JUnits, and then the consequence of the test could be either I found no bugs so far, so I will simply just go back to the edit, or maybe I found some bug. In that case, I'm going to use debugger to really debug over here. So you can think about the reason that we will use a debugger is because in the previous stage for testing, we have used JUnit test to find the bugs. That's how you can think of it. Make sense, Michael?
Yes, it does. Thank you.
Very good. Okay. Yep, nothing wrong with the flowchart, guys. You know, I don't want to say anything negative about it. I'm just saying it's just one way to really train your minds. But I would say in 1022, the code that you're going to deal with, especially starting from later weeks, flowchart may not be the appropriate level of abstraction you want to use. You may just want to stick to either to trace the code on paper, like what I have done to you for you in the lectures or the tutorial videos. That will be something you want to train yourself how to do it. And number 2, how to use debugger. All right. Bottom line, back to your fellow students' question. Console way, try to reflect yourself maybe 2 years from now. So 2 years from now, most of you or all of you will be in the 3rd or maybe 4th year even, okay? In that case, think about yourself. Are you still using the console way to debug your program? If you still are, nothing wrong because 80% of the people do that anyway. However, if you're really doing your debugging using a debugger properly, even for not so difficult errors, I think in that way, I think you're prepared to be a disciplined programmer. That's my take. All right. Guys, any more questions before I talk maybe briefly about programming test number 1? Any more questions? Everybody's okay? All right. Okay, so now let me talk briefly about programming test 1. I think mainly, I don't need to just reiterate the policy together with you. I think if you go to the PDF for your programming test number 1, So I already talked about it in the PDF very clearly about the policy, the rules, and etc. Let me just highlight a few very important points very quickly, and then I'll take a question. You might have some, okay? So number one is going to be next Wednesday and also Thursday, right? Specifically, it's going to be from 2 p.m. Wednesday to 2 p.m. Wednesday, right? EST. And then you're going to have 90 minutes. All right. And you can read the policy here about individual work. I'm sure all of you will obey that. And also, notice that for the 90 minutes over here, so please understand that 90 minutes is not just for you to implement the methods, right? So as soon as you start the test, as you can see from the practice test, a timer will actually start for 1.5 hours, like a 90 minutes over there. So you want to make sure as soon as you start a test, you got 90 minutes to do the following, right? I listed the workflow. You got to download the starter project's archive file. You got to import it into Eclipse. So if you got to practice really. So hopefully this will take no more than 2 minutes, hopefully, right? And then you're gonna do your job about completing the methods, and then you want. I would suggest be a little bit more reserved, be a little bit pessimistic. Leave at least 5 to 10 minutes to make sure you can really make sure you export the project and also upload and submit to eClass. At the end of the day, eClass will simply, as soon as the timer goes down to 0, no submission will be accepted. And then we're not going to accept any email attachment. It's going to be a very strict policy among all the sections. So please make sure you really practice the workflow. All right. Okay. And then let's see this. Oh, also something very important, because it does happen, again, in your fellow student in 1021, when we were still on the campus. You want to make sure, because remember, you're going to download the starter projects, right? For example, to your desktop, and then you're going to import it into your Eclipse. You want to make sure when you submit, you don't actually submit this very original starter project version that's on your desktop. In that case, nothing will actually give you credits, right? So just please avoid this common mistake. You want to make sure before you click on the submit button, you may just want to re-download the draft. You just upload it to the eClass, and then to make sure unzip it and make sure the utility class inside there is really the one you want to be graded. All right, that's very important, because if you submitted the wrong version and just email me after your countdown has gone down to 0, nothing I can do, I'm afraid. All right. All right. Okay, I think these might be what I need to say. Okay. Okay, everything else has been said very clearly in the instructions, but I would like to take your question if you got any for programming test number 1. Guys, any question you want to ask me about programming test 1? Those 2 minutes and last 5 minutes are going to be so crucial. Yes, I agree with you. Absolutely. That's why I really try my best to really give you the programming practice test that really simulates the workflow. So you really want to get used to it, right? So yeah, true. On the bright side, your programming test number 1 is 5%, right? We don't want to make it very heavy for the first one. So just do your best, right? But hopefully you will just be fine as long as you practice. All right, from Connor. What sort of resources are we allowed to use while doing the test? You know what? It's a good question. Okay. So I would say the bottom line, it is an open book test. So now let me tell you what you cannot use. How about that? Forbidden test. Okay. Sorry, forbidden resources. That's what I meant to say. For example, your friend So here, when I say your friend or fellow students, your fellow student may not be your friend, but that's what I meant. Meaning that you cannot, for example, have some Discord channel and then simply just post a solution there. I can tell you that we're going to do plagiarism check on every submission. If we find any suspicious similarity between the submissions, we will examine that and then report to Lassonde. Okay, we'll take it very seriously. Okay, so we also want to be fair to the majority of you who are honest, right? For the honest students, the worst thing we can do to them is to tolerate cheating. Okay, so guys, please just obey the policy. So you definitely cannot talk to your friend or any fellow students about any part of your test. You just cannot. All right. So let's say, okay, that's the thing that's going to be forbidden for sure. What can you use? You can use, for example, your own lab solution, and also any example code available made available by your instructor. And over here, I know you guys are from section M and N, but here I can be very general. So even if you use maybe some sample code made available by section O instructor, that will be okay. So N, and also O. All right. One thing to say here, okay? I'll just say, for example, let's say one of the methods you are going to implement is actually in the programming test number 1, it's about rock, paper, scissors, right? Let's say, for example, and somehow you simply just Google for that method, and somehow you're lucky, you simply just got a solution from there, and you simply copy and paste and get it to work. I would say in that way, you might also be caught cheating because your other fellow student might also do some similar Google searching. In that case, if they find the same website, the same piece of code, and they also copy and paste and then try to adapt it, in that case, you will end up having very similar code. So in that case, you will be caught cheating for sure, right? So I would say second forbidden resources will be code found on the internet. You might still take a chance, in which case I would say if you take a chance and then somehow if nobody actually just search the same resources as yours, in that case maybe you can get by, but I would say don't take chances. All right. You know what, Armin, you asked a very simple interesting question. Okay, you basically said, can you rewatch the tutorial videos on the test? You know, yes. Yes, I think that's okay. So you can think about tutorial video will be considered something that's made available by your instructor, who is me. So that will be okay. However, I would say you got very limited time for your test. So I suppose you wouldn't have to watch a majority of that, right, for the video. I guess maybe just some parts. That'll be okay. All right. All right. Hopefully that answered the question from, I forgot, from Armin. Okay. Is it from Armin? Let me see. You got some question on the chat. Yeah, Armin. Okay, good. Okay. I'm just trying to go over the chat question over here. Let me just see. Yeah, so what resources? Oh, Connor. Actually, Connor. So not Armin, Connor. So to Connor's question about resources that's forbidden and resource that's permitted, right? You already know the answer. So basically, you can use any code you have written on your own, or you can use any code that's made available by your instructor for 1022, or you can use a tutorial video. That's it. That should be enough. If you try to use anything on the web resources, you're taking a risk. So I would suggest you don't do it. All right. Okay, from Armin, do we have to draw a flowchart on all of the programming tests? So Armin, do you hope to draw a flowchart or you hope not to draw a flowchart? Let me ask.
I hope not to draw a flowchart because it saves time.
Yeah, so we'll follow your opinion then. Yeah, let's not do flowchart. So answer is no. All right. Yeah, so guys, I think you might be a little bit terrified because I did mention flowcharts in your selections lecture. I think the reason I put it there was because to introduce the syntax and semantics for if statements, flowchart definitely helps in the very beginning. But as I said, once you go beyond the simple code level, flowchart to me does not really help much. So for your test, don't worry about flowchart. All right, don't worry about it. Okay, so Armin, about to which week will the programming test cover? Okay, I think that's already mentioned in the PDF, but until week number 3. Okay. Yeah, I think that'll be reasonable because week number 3, you think about for lecture, week number 3 Java tutorial was released last Friday, right? And also for week number 3 lecture was released officially today, and then you got until next Monday to really ask me a question, about the lecture. So I think it's fair, all right? But for week number 2, for week number 4, for tutorial, I'm going to release week number 4 on Friday, and also I'm going to release a lecture maybe Sunday or Monday. They will not be covered, okay? So AV sample code made available, including from the lecture tutorial that I do in the videos. Yes, that's correct. Anything I did in the videos for the tutorial, feel free to use it if you find it useful. Okay? All right, let's see. Can we use IntelliJ on the test? Armin, I think, to be honest with you, I want to give you my honest opinion. I don't think you want to. I tell you why. Because when you download the starter projects from the E-class, it's actually in the Eclipse format. I'm not sure what's going to happen if you try to import a Eclipse project in IntelliJ. If you simply just recreate all the packages and also everything, just copy and paste everything from Eclipse and into IntelliJ, that's okay. But the problem is when you want to export this file for submission, in that case, you're going to waste time. I would say if you find a workaround, I would say do that workaround in the labs. Don't do that for the programming test. You want to save some time in case the methods, you're going to spend some time debugging. So I would say no, okay? That's what I recommend, right? Of course, I don't check. Okay, something from Michael here. A little bit scared for these tests. There's not a worse feeling than writing the code for a question and getting the right solution. Yeah, well, Michael, I agree with you. This is how I like to put it. Of course, I passed that stage already myself, so I can only share experience with you. It sounds like a cliche, but before you can make any intellectual growth of yourself, there should be a struggle. Meaning that if you want to really be a better Java programmer, it doesn't happen just right away. You have to struggle a little bit to see, I just don't know how to make a progress, how to jump this tip of the mountain. However, once you get through that feeling, I think things will improve. So I understand. So, but thinking this way, we're going to have 4 programming tests for the semester. So you want to get used to it as soon as possible. What can really make you feel a little bit better during the test would be you want to practice as much as possible, not just by the tutorial video example I gave to you, maybe not just by the lecture example I gave to you. You want to maybe find some practice problems as well, maybe from the web, right, to really try to use them. So the more you practice, I think the more confident you will feel during the test. So that's my best advice. Okay, I would say struggling for the test, if you're a beginner Java programmer, I think that's absolutely normal. But I think at some point you got to get through the struggle. And you should feel lucky that you only get through the struggle in the first year. If you still have to struggle in the second year or even in the third year, I have seen students like this. They're still struggling with the basic programming, even in the second and third year. That really drag them behind very, very badly. So I think try to take this opportunity to really get through the struggle, right? But if you want to talk about how you make it better prepared, drop by my office hour and I'll speak to you, right?
Thank you, Professor.
No problem, no problem. AV, okay. So I think AV, I wouldn't get into talking too much about how we determine cheating. We do have a way that's actually systematic and also fair to really determine. Thinking this way, the determination of the decision on whether 2 students really cheat, are not done automatically by computer because computer can make mistake. You can think about we kind of use computer to scan through everybody's submission, and somehow the computer has some intelligence to tell us who might be suspicious. And then some good TAs who know very well about Java are going to look into the submission who might be suspicious deemed by the computer, and then myself will also look into it. We'll actually try to see if the students simply just copy each other. So we will be able to see. So you don't have to worry if you simply just did your own work without copying each other, copying anyone else other than just working on yourself. You wouldn't be caught, don't worry. Yeah, all right. Let's go a little bit further here. Just write your own code. No need to worry. Yeah, exactly. So just write your own code, then you will just be fine. All right, no problem. Guys, any more questions? I can totally appreciate your feeling. When we were running the classes in person, I think that we try to, in some way, we try to run the so-called lab test in the Williams Small Center. Maybe you haven't got a chance to go there. It's like basically a lab with about how many? Maybe 48 machines in the room, and then all of your colleagues actually take the test simultaneously. In some way, you might feel a little better because you're actually doing that together with your colleagues. But now you're doing that alone in front of the computer, and then you got some time constraint. I totally understand, but I would say that's something you just want to get through it, right? Once you get comfortable with to really program under pressure, think about if you go to a job interview, you definitely stress out because your interviewer might simply just give you some problems that you simply don't know how to solve in the beginning. So what can you do? You simply just cannot just freak out and then simply tell them that you just cannot handle the stress. In that case, would they hire you? I guess not, right? So I think you want to just try to learn how to deal with stress. I think that will be the best advice I can give to you. And then for your future courses in second year or even in the third year, I know that many of my colleagues, they also like to run computer-based tests because in some way, when you can really work under stress, that's also a soft skill you have to pick up. You should not always assume you're going to work under no stress. That's not realistic. Okay. All right. Guys, any more questions about programming test? One more thing I want to say. I know that you guys are worried about the programming test. I understand that. So that's why for your upcoming lab, I believe lab number 3 is going to be about for loop or while loop. I'm going to make it quite straightforward, but I'm still going to do some exercise about programming every week. So you will still get your lab, but just going to plan your time. And if you look at your calendar, let me just mention maybe the final thing. I don't see any new questions over here, so I can talk about this. Maybe this will be our final topic for today. If you look at your semester calendar over here, if you go there, let's see where we are right now. We are basically over here, 25th, right? You will have your programming test, test 1, next week, all right? And then for your written test number 1, it will be the week after, all right? I'm going to give you a guidance about how you should get prepared for your written test number 1 around here, maybe around at the end of this week. I'll give you the guidance, okay? And then, however, I would say for the written test over here, as long as you have been following through the tutorial videos and also the lectures, you will be okay, right? And I'm going to give you some example tests to really get you familiar with the formats on E-class. But you might have taken some quizzes anyway on the E-class. So the format shouldn't be a surprising factor to you. But I think for the written test, it will be quite important for you. For those of you who might be behind in catching up with the lectures or tutorial videos, now would be the good time to really catch up. Otherwise, you simply don't want to say, I'll wait until maybe the weekend over here and then watch all the previous 4 weeks of lecture, about 8 hours. It's not a way to go. I can tell you that it's not going to work well. All right. All right, guys, any more questions? Any more? Everybody is okay? All right. Just for your information there, we still got, guys, you're very welcome. For tomorrow, we still got our Q&A session there. I wouldn't expect too many of you might show up. That's okay. But I think for tomorrow, I would say if you really got any more questions related to your programming test, feel free to come. I think for now, the best you can get prepared will be just to go over the practice test and then try to practice some additional problems. That's your best way to get prepared. All right. All right, guys, I think you're fine. All right, I'm gonna stop the recording now, and then I might see you tomorrow. Otherwise, later. All right, you take care. Bye-bye, everyone. Take care.